So in the previous video, we've looked at sketching quadratics and the key bits of information we have to calculate when sketching them if we're giving something in a standard quadratic form. So ax squared plus bx plus c. What we're going to look at today is still sketching quadratics a bit, but we're going to look at what happens if we've got a graph and it's written in completed square form. So that's our x plus a squared plus b, that kind of form there. We're going to look at how this can impact the way we sketch the graph and actually how it can help us with certain bits of information. Now, if we remember back to when we sketched graphs and quadratics in general, there are three key things that we needed to do for every single graph. Three key bits of information we needed were the y-intercept, the roots, and the turning point. Now, if you think of the general shape of any quadratic in the world, it will always cut the y-axis. It will always have a y-intercept. The shape it is it goes from negative infinity to positive infinity, and it's a curve that's almost like a cup or an upside down bowl. Regardless of which one it is, it will cut the y-axis at some point. Where that point is, we don't know offhand, but we can calculate it fairly easily. It will also always have a turning point. Any quadratic will always turn back on itself. Whether it's coming up, it turns back and goes down, or it's coming down, turns back on itself and goes up. But the roots are something that could be different. Now, if you think about the discriminant of a quadratic, there were three outcomes to that. We had b squared minus 4ac could be bigger than 0, equal to 0, or less than 0. Now, if it's bigger than 0 or equal to 0, we got at least one or two roots. However, if it's less than 0, we get no roots. Now, what this means is it doesn't actually cut the x-axis. Now, this was a vital bit of information for us in our quadratic sketching because this allowed us to get the turning point. Without those two roots, we couldn't find the centre of them. We couldn't then use that to get the turning point of the graph. So how would we do that? Well, that's where completed square form comes into play. Now think about completed square form. This is what it looked like. So we had y equals x plus p squared plus q. This is where we got to at National 5 level. At higher, we ended up introducing an extra part here, a coefficient. So we'd end up with y equals a bracket x plus p squared plus q, or y equals q minus a bracket x plus p squared. So this was something like your 2x squared plus 4x minus 7 before it was put into brackets. Something where the x squared has a coefficient. Now they are still quadratics and they still have a turning point, so we still have to be able to calculate them. But using completed square form, we can actually just read it off. Now, what I want you to remember is this. Whenever we have a graph and it's written in completed square form, the turning point is always given by the value negative p comma q. We always get that. Now, a key thing to remember is if a is positive, it will be a minimum, and if it is negative, it will be a maximum. So in this sort of case here, a is positive, the value outside the bracket is positive, so that means when we multiply everything out, we'll get an x squared. So we get a positive x squared, which means it's coming down and it's going to go back up. So it's going to be a graph that looks something like that. With this one here, it's a negative value for a, so when we multiply it out, we get a negative a squared. This type of graph is one that comes up and down, but again, a key bit of information, they both have a turning point, and this lets us get it. So let's have a look at a couple of examples and how we might use that to help us sketch the graphs. So let's imagine I want to sketch y equals 2x squared plus 4x plus 7. Now if we were to look at this and we were to do b squared minus 4ac. So let's do our a, our b, and our c. So a is 2, b is 4, and c is 7. We would get 4 squared minus 2 times 4 times 7. So we'd get 16, take away, well, 2 4s are 8, 7 8s are 56. 16 take away 56, which is negative 40. Now that tells me b squared minus 4ac is less than 0. So that's got no real roots. So that means it doesn't touch the x-axis at all. So if we imagine these are our axes here, there's my y and my x. This graph doesn't touch the x-axis at all. It's a positive x squared, so it'll be up here in the air somewhere. So we can't just use the roots to calculate the turning point. So to do that for this one, we still have to calculate the turning point. We still have to calculate the y-intercept. That can easily be done. Our y-intercept is still done the same way. We still set x equal to 0, and we still plug it in. So we get y equals 2 times 0 squared plus 4 times 0 plus 7. In this case, y equals 7. So we know the y-intercept is still going to be somewhere up here at 7. But we want the turning point. Now to get that, what we have to do is put this in completed square form. So think back to when we did that, when we did the video on that. We'd start by taking the 2 out as a common factor and have 2 bracket x squared plus 2x and then our plus 7, our bit on the end. We then focus on this bit here and put that into our completed square form. So we'd have x plus 1 all squared, take away 1, so our correction factor, with 2 on the outside, and then a plus 7. And then it's just a case of simplifying this all out. So we get 2 bracket x plus 1 all squared, minus 2 plus 7. So we get 2 bracket x plus 1 all squared plus 5. So that would be what the function would look like in completed square form. Now from this, I'm able to get the turning point by focusing on this term and this term here. Now imagine that this was what we called P and this is what we called Q. Our turning point, remember, was given by negative P, comma Q. So in this case, my turning point would be at negative 1, comma 5. So I could mark that in here by going to negative 1 and then up to 5 there. So there's my turning point at negative 1, 5. Now I've got enough information that I can do a sketch of this graph. I can do a sketch of the curve on my set of axes here. So I'd have my curve going off in this direction, it would go up through the 7. Then I'd have the quadratic going off in this direction, up that way as well. And from that I can label it. So I'd get y equals 2x squared plus 4x plus 7. So I'm still able to sketch it. I'm still able to get my turning point and I'm still able to have a sketch of the quadratic. It's just this way I have to get it using the completed square form because I don't have any roots. I don't have anything because my b squared minus 4ac is less than 0. Here's another one for you then. Imagine I've got y equals 5x squared minus 30x plus 46. Again, I could look at this and do my b squared minus 4ac to see what I get for that one. So in this case, b squared minus 4ac equals negative 30 squared, take with 4 times 5 times 46. So b squared minus 4ac, negative 30 squared is 900. Take away 4 times 5 times 46 gives me 920. That gives me negative 20. So I know that that's less than 0, so I'm not going to have any roots. It's not going to cut the x-axis again, so I'm going to have it like that. And it's a positive x squared, so it's going to be a curve coming down the way and back up. So again, I find the same key bits of information. I want my turning point and my y-intercept. So my y-intercept I get by substituting in x equal to 0. So it's y equals 5 times 0 squared. Take with 30 times 0 plus 46, which in this case is just equal to 46. So it's quite a high y-intercept, but that doesn't make any difference. It's still up there, it's still at 46. I then put it into completed square form. If I do that, I then get where my turning point is. So start by taking out my common factor, so I get 5 bracket x squared minus 6x, close the bracket, plus 46. We then focus on this part as we do all the time. So I get x minus 3 all squared. Take away, well, 3 squared, remember it's this bit here that's the correction factor, gives me the 9. Then got the 5 outside and my plus 46. At this point, I can then start to simplify the whole thing out. So I get 5 bracket x minus 3 squared. Take away 5 9s are 45. Plus 46. And I can then simplify and get 5 bracket x minus 3 squared plus 1, and there is my function in completed square form. So from that, I can read off my turning point. Now remember, it's negative p, q, the p is the part in the brackets, and the q is the part at the end. Q is 1, p is negative 3, remember the sign goes with it, so it's minus minus 3, so my turning point is at 3, 1. Taking that, I can then plug it in here, so I can see right, my turning point's along here at 3, and then down there at 1, so it's 3, 1. I can then say, right, I've got all the information that I need, I can now sketch my curve. So I can come down this way, through my y-intercept, get there, and off up to infinity. And again, key thing we have to make sure we do is label it y equals 5x squared minus 30x plus 46. Using completed square form actually is a fairly straightforward method. It allows us to do this a little bit more efficiently and quickly. But the key thing it allows us to do is deal with quadratics where there are no roots. It doesn't cut the x-axis, so it allows us to deal with these curves and still plot the graphs fairly accurately.